taking these points, because we've kept it pretty simple here, we've gone from the simplified shapes, the circle, subdividing with points. Now we're going to take all of that data and subdivide those points evenly. Now, when we have all of these points and we know that we've gotten rid of the redundant ones, now we can bring in the Voronoi subdivision. Now, before I go too far with the Voronoi pattern, I want to explain that Voronoi is actually a process of subdividing areas evenly. And so this is why you see it used a lot, is because it's a straightforward process, but when you use it with random points, it actually creates a very noticeable pattern, and people tend to not like or to overuse it. But in this case, we have something different. We have the ability to take all of those points that are not random, because we're using organized systems to create patterns like this. So as you can see, Voronoi, it's actually creating the geometrical patterns that we want to extract by taking all of those points and subdividing it evenly. Now, you would never look at this pattern and say, wow, that's the process of Voronoi is being used here. But you can see that as we change the frequency, we change the pattern. And what we're doing is we're subdividing each and one of those points evenly, so we can see how this reacts. The next thing we're going to do is, now let's change the maximum. So 9 is the max on this one. I'll change it to 20, and then you'll see how intricate these patterns can get. And when you look at old churches and old cathedrals, I can't help but to realize that some of these simple geometric steps are being used to create some of those very intricate shapes and patterns that you see in classical architecture. So this is why I wanted to share part of this process, because I feel like it's a very simple one for many people to get started with, and it can also give you insight as to how to create patterns and how simple it can be, as long as you know what your steps you're taking from the beginning.